So today we will go through some more examples. We know how to write the lambda expression. For that we need to use the functional interface. To write the functional interface, there is going to be one criteria, which is we are going to have single abstract method in the interface to call that interface as the functional interface. Now we know how to write our lambda expression. Suppose this is the functional interface. We want to provide the implementation for this single abstract method. So we are going to write this parenthesis, this logo, open the bracket and close the bracket, and inside those brackets we can write the implementation, write the body, as we write the implementation or body inside the bracket in simple Java program. To provide the implementation for this method, we have to open the bracket and close the bracket, and between those brackets we write the implementation. We are doing same thing, open the bracket, close the bracket, between this bracket we write the body, or you can say implementation. That's how you can provide the implementation for this single abstract method of any functional interface. What if this method is going to have parameters? Let's say this method is having parameter, suppose of type int. Then what we are going to do to create the lambda expression, we have to write the single abstract method parenthesis with the parameters. So this is the parameter available. We have to write the parenthesis, and in parenthesis we have the parameters. We will write that parameter right here, a, and the name of the parameter, name of the variable doesn't mean you can write anything right here. And then you use this bracket, use this column, open the bracket, close the bracket, between those brackets you have to provide implementation. You have to provide implementation for this single abstract method. So you provided the single abstract method, and this lambda expression got saved in the reference variable of type the functional interface. Now with this reference variable of type functional interface, you are calling this single abstract method. So when you are calling this single abstract method, you have to provide the values right here when you call any as an argument. So this line is the caller of the method, single abstract method. This line is the caller of the method. So in the caller of the method, you have to provide the argument that a method takes as a parameter. You know this is basic Java. I'm writing 500. And the functionality, the implementation for this single abstract method is written in the lambda expression, and lambda expression reference is stored in this reference variable, and that with that reference variable we are calling this method, single abstract method. So this is the caller of the method. We are passing the argument 500, and the implementation is here in lambda expression. So what will happen? This lambda expression will take this 500 and print that 500, but it is not going to be printed. You can see here. Basically it is giving error. It is not giving error because it is not going to print it. Let me tell you that why it is not going to print first. Suppose this is a normal Java program. So there is an interface. This is an interface. Inside this interface, there is a parameterized single abstract method. Now, when we are providing implementation for that single abstract method, we have to write that parameter right here. And for that parameter that we are going to pass at the time of calling that method as an argument, there should be something happen with this parameter. So let's print that parameter. We are printing simple parameter right here. At the time of calling, we are passing 500. Let me show you, otherwise you will get confused. This is a Java program, functional interface having abstract method with parameter implemented in a class. We are overriding method. We provided the implementation, open bracket, close bracket. Now we created the object of class. With that object, we are calling this method, and at the time of calling this method, this is the caller line of this method. We are passing 500 as an argument. So the 500 will be printed. This method will be invoked, and this 500 will be printed. 500 is getting printed. Exactly same like this. If you are doing this as a lambda expression, single abstract method is in interface. For that abstract method, we written parentheses with parameter. We use this logo, open bracket, close bracket, and between this bracket, we are closing bracket here. Between this bracket, we have to provide the body. So here we provided bodies like this. We are printing the variable that is coming from the argument, value that is going to come in from the argument as a parameter in the parameter. So here we are going to provide the value 500 that is coming here. We have to print this value. So let's print this value as D. Now run this program. Let's say 40. It is printing 40. I think you got the idea. What will happen if we are going to have multiple, suppose string name. So this we are going to write parentheses with the same parameters. String n, or you can write name, but it's not required. SG will get printed, and let's print n at the time of calling that method. Calling this method, we are going to write, we are going to pass the argument that this parameter takes. It takes Raj. So 40 and Raj are getting printed. What if this method is having return type? Int is of return type. So int is of return type. Suppose right here, this method is having return type int. Then in the class, we have to provide return value. We have to provide a return statement for this method. As you can understand, I'm assuming that you are understanding because you know Java. This abstract method is having return type int. We are implementing it in a class. So we have to override the same method and we have to return. When we are providing implementation, we have to provide the return type, return statement. And at the time of calling, when we are going to pass 500, it is going to return 500. So this method, when we are going to call this method is going to return 500 because it is having int return type. So this method is going to return int type return type. So we are going to store that in the corresponding primitive type. Exactly like that. This is the implementation. Open bracket, provided the implementation and close the bracket. Now there is a return type in our implementation when we are doing it with Lambda expression. There is a return type in single abstract method when we are doing it as an method, that's an Lambda expression. So we open the braces, close the braces, but before closing the braces, we have to provide return type right here. So you can write return, return, return. Let's say return type is going to be LD. The thing we are going to pass here, that comes here, and this thing is going to get returned. Let me make it simple for you so you can understand. Look, it's easy. Open bracket, close bracket. Open bracket, close bracket. The open bracket, we provide implementation and return type and close bracket. The open bracket, we provide implementation, return type, same return type, and we closed our bracket. Okay. Now, when we are going to call this method, this is going to return int. So this method is going to return int type parameter. Let's save that in A. Let's print that in A. You can say 140 and Raj is getting printed from the method when method is getting invoked, and then that method is returning of type int that we are catching right here in this primitive type A, primitive type int variable A, and we are printing that variable. So you got the idea, you got the use cases, you got the possible cases that can arise when you are working with Lambda expression. Now let's go back. To our notes. Why Lambda expression? Reduce code length. You can see this much of lengths and only these simple lengths. This is looking complex because this is not in single line. You can write all this in single line. Look how simple is this. First you write the interface in way. If you go with simple Java programming, you make an class, then in another class you are calling that method. There is a simple single abstract method in a functional interface, and from there is a class where you are calling that single abstract method by using the Lambda expression. It reduces the code length, increase the readability. complexity will be reduced. Simplify the inner classes. These are the inner classes, basically, you can say. Instead of doing this right here, we can write this. We can implement hello interface in this class and override this method in print class itself and call the same method from the print class. But we have gone in this way, so we can say that it is simplifying the anonymous inner class. Sweet syntaxing. When we are reducing basically the code length, we can say that we are doing sweet syntaxing. We can reuse the lambda expression. Here you can say a dot show one, not a dot show one. he lambda expression is in this reference variable he dot show one. This time let's pass another value, suppose 8000. Suppose Kumar. This method is going to return primitive. Print this primitive. So we are using lambda expression again and again. Here we use lambda expression he dot show one. Here we used again lambda expression show dot he dot show one. So reduce the code length, readability will be improved, and we can reuse the lambda expression. Interview question for lambda expression. So you can answer this all as we have seen. Go through this. I am going to provide this PDF in the description box again. You can go through this interview question. These are the only interview question that any interviewer can ask you about the lambda expression of Java 8. Method reference is another features that came up from with the Java 8 or with the JDK 1.8. We are going to cover this from the next video, so stay tuned.